Okay, students, today we're going to talk about expected value and fair game. So let's just say we're going to roll a dice 120 times, okay? And the question is, how many times would you expect to get a 6? So you know that you've got a 1/6 chance of of getting a 6, right? So if you've got a 1/6 chance of getting a 6, and you're going to roll it 120 times, then you would expect that um, 20 of those times you would get a 6, because if you think about it, we know that our probability is 1/6 chance of getting a 6, and if you're rolling it 120 times, multiply those together, and then that's going to tell you how many times you expect that you're going to be getting the number 6. And 120 divided by 6 is going to give me 20. And so we expect 20 times to get the number 6. So this equation simplifies to the expected value is equal to the number of trials for the experiment and the probability. Okay, so let's do the first example. You've got a football player, and he's got a 3/4 chance of being successful, and he's going to kick the ball 12 times. So your probability is 3/4. So to figure out the expected number of goals, you're going to multiply the fact that he's going to kick the ball 12 times and your probability of 3/4. And so we expect that he's going to get the ball 9 times. All right. Now we got another problem or question. So the goalkeeper probability gets a 3/10 chance of saving the penalty, and how many goals do we expect to save out of 90 attempts? So our number of trials is 90. Our probability is 3/10. So when you multiply those two together, you expect that you're going to get 27 goals. Okay, question number 2. You're going to roll a cube, and the cube has 4 faces that have red and 2 faces that have blue. Okay, so we've colored the die. On any roll, what is the chance of obtaining red? Well, if four sides have red, then we've got a 4/6 chance of getting red, or simply 2/3, right? And you're going to roll the die 3 times. So if we're going to roll the die 3 times, 3 times our probability of 2/3, we would expect to roll red twice. You may want to hit pause and replay if you need to see this some more. Okay, so now we're going to do expected value after a spin. So if we spin this spinner, we've got the probability of getting each number 1/4, right? Here we got the probability of getting a 10, 1/4, right? Each of these probabilities is going to be 1/4. Because the spinner breaks up these into 4 equal parts. So we want to figure out what is the expected value when you spin the spinner. So if I land it here, I've got a 4th chance of getting 50, plus a 4th chance of getting 15, plus a 4th chance of getting 10, plus a 4th chance of getting 5. So we find each of these probabilities, multiply it by the expected value, and then add these together, and then we expect on average that after a long time of spinning this, you're going to get 20 points. Now, of course, it's impossible to spin it once and get 20 because none of these are actually 20, but over many, many spins, the average of the scores is going to be 20. So what we just did here is we had our probability times the experiment outcome, and we take the sum of each of these things. So we had this one here, plus this one here, plus this one here, plus this one here. So when you get the sum of all of these, that's going to give us our expected value. And this funny looking shape here is called a sigma, and it's a Greek letter that means sum. Okay, and so we're getting the sum of all of these things. So let's look at our first example. So you've got some magazines that are being sold, and in 1 week, 23% by one magazine, 38% by two magazines, 21% by three magazines, 13% by four, and 5% by five magazines. So here are our probability percents, and these are the number of magazines that are purchased. So in order to figure out our expected value, you multiply the probability times the number of magazines. 0.38 times 2. 0.21 times 3, 0.13 times 4, 0.05 times 5. Okay, and then we get these values here, and we add them all together, and the sum is equal to 2.39. So over a long period of time, we expect on average that a person's going to purchase 2.39 magazines. Now, of course, in reality, we all know that you can't buy 0.39 of a magazine, but on average, this is what mathematically it calculates to. On the test, make sure you round to 3 significant figures, okay? Okay. All right, next. So here, question 3. When the spinner alongside is spun, the players are awarded certain points. On average, what do we expect that we're going to win? So we have a third chance of winning each of these. So a third chance you're going to get 5, a third chance you're going to get 10, and a third chance you're going to get 20. So multiply these together, and you're going to end up with 5 thirds plus 10 thirds plus 20 thirds, 35 over 5, which gives me 11.7 points. Let's look at this example here. We're going fishing, and the probability of getting no fish, 1 fish, 2 fish, and 3 fish is these probabilities. So once again, we multiply the probability times the number of fish. Add these all together, and we expect to get 1.57 of a fish when he's going to go fishing. Okay, same topic, but now we're going to talk about something called fair game. Okay, so in gambling, we say the expected gain of a player and the return of the payout from the game minus the amount it costs to play the game. So in order for it to be fair, the expected gain needs to be 0. So let's look at this first example. So the expected gain is the expected return. So, okay, so we're going to figure out the expected return, so the expected value. So we're spinning a spinner, and it's either going to land on a 1, 2, 3, or 4. So since it's a spinner, we've got a 1/4 chance of getting each of these here. Okay, so our probability is 1/4 for each of these here. Okay, and so on. So we have got a 1/4 chance of winning $1, a 1/4 chance of winning 2, a 1/4 chance of winning a 5, 1/4 chance of winning an 8. Add these all together. Our expected return is $4. On average, after spinning lots and lots and lots of times, you're going to win on average about $4. So, question B, what the expected gain of a player if it costs $5 to play a game? So if it costs $5 to play the game, your expected gain is the expected return minus the cost of the game. So if I expect a $4 return and I'm paying $5, my expected gain is negative $1. So basically, after playing this a lot, on average, I'm going to lose $1 every time I play this game. So because the expected gain is not equal to 0, the game is not fair. Okay? You may want to hit pause and think about this. Okay. You're rolling a die, and it costs $2 to play a game. If you get an odd number, you're going to win $3. If you get an even number, you're going to win $1. So when you're rolling a die, there's a 50-50 chance that you're going to get an odd number and a 50-50 chance you're going to get an even number. So I'm going to use 1/2 as my probability times $3 and 1/2 times $1. So multiply and add those together, we get $2. And it costs $2 to play the game. So my expected return minus the cost of the game is 0. Therefore, the game is fair since the expected return from playing the game is 0. Okay, last question. Okay, this one's a little bit trickier. You're playing a game and you're pulling out discs from a bag. 10 black discs, 4 blue discs, and 1 gold disc. Okay, you're going to win $1 if you pick a black disc. You're going to win $5 if you pick a blue disc, and $20 if you pick a gold disc. And the game costs $4 to play. So calculate the expected gain for the game, and hence show that the game is not fair. Okay, so total number of discs, 10 plus 4 plus 1, we've got 15 discs. So I've got 10 out of 15 chance of getting black, 4 out of 15 chance of getting blue, and 1 out of 15 chance of getting gold. All three of these should add up to 1 for probability. Okay, so what is the expected return? So 10 out of 15 chance if we win, we're going to get $1. 4 out of 15 chance if we win, we're going to earn $5. And 1 out of 15 chance if we win, we're going to earn 20. Let's add these together. 10 fifteenths plus 4 times 5, 20 fifteenths plus 20 fifteenths. Add those together, you're going to get 50 over 15, which is about $3.33. Okay, so since $4 minus this is not equal to 0, the game is not fair. If it was equal to 0, the game would be fair. Okay, question B. This was the tricky one. To make the game fair, we're going to make the prize money for selecting the gold disc. We're going to change that. Find the new prize money for selecting the gold disc. Okay, so instead of saying that this is worth $20, we're going to say that it's worth X dollars. Okay, so we want to change this value instead of 20 so that it's fair. Okay, so and we know that you're going to pay $4 to play the game. So we have 4 equals 10 fifteenths plus 20 fifteenths. Well, 10 fifteenths plus 20 fifteenths is going to give me 30 over 15, which is 2, right? So now I've got 4 equals 2 plus x over 15. Well, subtract 2 on both sides, you get this. And then you end up with x equals $30. Okay, so the new price of the money for the gold disc should be $30 if we want it to be fair. Rewatch this if you need extra help, and I hope this helps.